Okay, let's look at that last example, example 6 in section 2.15. So we have the linear model for a semi-log plot. So we know an exponential equation, y equals a times b to the x, is going to appear linear when plotted on a semi-log plot. So on the previous example in class, we did that conversion ourselves. We took the log of both sides, and we split the log of the products and then brought the x out front, okay? So we derived it ourselves, but here they have it already written for us. Every time that linear model, okay, and so this is what I'm calling our log of y. This is our y, capital Y sub L, which is the log of y. Okay, and this linear model is going to be, because that's on the logarithmically scaled y, that's what we're doing there, is going to be log base n of b times x plus log base n of a. And of course, we're choosing log base of 10 because we're scaling it with a base of 10 on the y-axis. Okay, so in example 6, it tells us to use the data from table 3, which is graphed here. I went back to example 3 and I pulled these first 2 points off that data. X was 1 when y was 40, when x was 2, y was 60. And now I just want to get the logarithmically scaled data, and I'm going to do that by taking the log of the y values. So log of 40 and log of 60. So this is our new log y values that we're going to use. All right, so here's our model here, same as that was written up there, and we want to build this model. Okay, so the first thing we're going to do, we know that the log base b of x is our slope in the linear model. This is mx plus b format, where b in this case, this is our y equals mx plus b format, just the point slope intercept, the slope intercept form of a line, where m is our slope. And this b is not the same as the base in our exponential function. And this b is our y-intercept, okay? So we're just following this model. So we know that the log of b just is the slope. And we all know slope, way back from algebra 1, is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Okay, so since we're doing our y sub L thing, our x values here can be the 1 and 2 that we have here, but our y values are going to be this log 40 and this log 60. Those are our points. Those are our xy pairs that we're using because this is the equation that we're building. So if I plug in, I'm going to use my second y value, which is log of 60, minus our first y value, which was log of 40, over my second x, which was 2, minus my first x, which was 1. Now, 2 minus 1 is just 1, so with a denominator of 1, I don't have to write it, so I'm not going to write my denominator. This is a difference of logs, so that I know that numerator is the log of their quotient, so that's the log of 60 over 40, which of course can simplify. Those zeros cancel. 6 and 4 are both divisible by 2, so that's the log of 3/2. So the log of b, way back here at the beginning, the log of b is just the log of 3/2. Okay, so we can start building our equation of the line. We can start building that equation of the line. We said it's y sub L, the log of y, right, is log of b, which we just decided was log of 3/2, just discovered or found was log of 3/2, times x. And now we still need the log of a. We still don't know what the log of a is, so we need to solve for it. And the way we're going to solve for it is we're going to use one of the points from our graph. So I'm going to choose this point right here. Okay, so I'm going to use the coordinate point 2, log 60. That's the coordinate point that I'm going to use. And I'm going to plug it into my equation. So plugging into that equation, I get that the log of 60 equals the log of 3/2 times x. Now, remember, multiplication is commutative, so I can leave it log of 3/2 times x, or I could bring that x to the front and do x times log of 3/2, and that's what I'm going to do. I'm going to plug into that x position, but I'm going to pull it to the front rather than leaving it in the back. So our x value in that coordinate point that we're using is 2, So that's going to be 2 times the log of 3/2. Why did Miss Weaver want that 2 in front? Because if I put that 2 in front, I think it makes it clear to you what you need to do with that 2, how we should handle that 2. How are we going to handle that 2? Well, those coefficients out front can be brought up as exponents. So we know the log of 60. Oh, and I still need to have my log of A here. So let me go make sure we get that plus log of A. Excuse me, is equal to log of 3/2 squared, right? We're going to bring that back as a power plus log of A. All right, so we want to start solving for that A now. So I want the log of A by itself. So I'm going to subtract log of 3/2 squared from both sides. So that's just the log of 60 minus the log of, what is 3/2 squared? That's just 3/2 times 3/2 or 9/4 equals the log of A. We, of course, know that the difference of logs is the log of their quotient. So I can do the log of 60 over 9/4 equals the log of A. And then let's just simplify that. If I multiply by the reciprocal, that gives me the log of 4 times 60 is 240 over 9, still equal to my log of A. And then those are both divisible by 3, so that just gives us the log of 80 over 3 equals, that's my A, equals the log of A. All right, and now we're ready to complete our equation of the line. So here's our equation of the line, and now that we know the log of A, we can plug that in. And so the answer to part A here, we needed a lot more space than they gave us, is that our y sub L, and I just did that, equals the log of 3/2 x plus, we said the log of A is the log of 80 over 3. Now, all that beautiful work makes the next part of the question very easy to answer. The next part of the question B says, using the linear model from part A, here it is, here's our linear model, okay, here's my answer. Write the equation of the exponential model y equals a times b to the x. Well, there's our model for us. It says lowercase y equals a, which we now know is 80 over 3, times b, which we now know is 3/2, to the x. And so super easy to get our exponential model. Okay.